Lesson 33, Exponential Functions. Lesson 33, Exponential Functions. The first thing we need to do is define what an exponential function is. We're going to do that by taking a look at these two tables. These two tables have two things in common. The first, they both have the same y-intercept of 0, 2. And the second thing that they have in common is both of them are increasing functions. But they're growing in different ways. If you take a look to see how the y values are changing in the first table, they are all changing by a rate of 3. 3 is being added to each of the y values to find the next y value. Whenever you add by the same number over and over again, you get a linear function. The equation for this function would be y equals 3x plus 2, where 3 is the rate of change. 3 is the number we add each time. The second table is also growing by 3, but in a different way. Each of the y values are being multiplied by 3 instead of added. Whenever we multiply by the same value over and over again, we end up with an exponential function. Seen in this graph, y equals 2, which was our starting point, and we multiply by 3 over and over again. Exponential relationships happen whenever we have repeat multiplication, and it has to be the same number. The general equation for exponential relationships is f of x equals a times b raised to the x power, where a is your starting value and b is your rate of change. That's the number that you multiply by every time. There are two rules for exponential relationship. That is, a cannot equal 0. If a equals 0, we have a horizontal line. That's not an exponential relationship. And this also only works if b is greater than 0. Say you want to write the exponential function that crosses through the points 0, 3 and 2, 48. The two pieces of information that you need are your a and b values. A is the starting point and b is the number that you're going to multiply every y value by. Good news is, whenever I give you a y-intercept, 0, something, I gave you the starting value. In this situation, a is equal to 3. We still need to find b. In order to find b, you're going to plug in the other 2 points you have. 48 equals y, and 2 equals x. So now that we have an equation with only one variable in it, we can solve for b. Take the square root, b equals 4. So now we have our equation of y equals 3 is your starting point, 4 is your rate of change. Y equals 3 parentheses 4 raised to the x power. These problems get a little bit more complicated when I don't give you the y-intercept, because now you have to solve for your a and b values. So first thing you're going to do is create two equations for each of your coordinate points. So the first equation we have is 200 equals a times b. The second equation comes from the other coordinate point, 8 is our y value. 3 is our x value. Don't forget that the x values are the exponents. And just like when we had 2 equations and 2 unknowns in the first semester, remember your systems of equations problems? Well, this is another system of equations. So we can use the idea of substitution to solve this problem. So the first thing we do with substitution is you have to isolate a variable. So then you can plug it into the other one. So the variable that you want to solve for is a. You always want to solve for a, because when the exponents get to a higher power, it's easier to plug things in for a instead of b. So here we have a equals 200 over b. And what you're going to do with that is you're going to plug that in to your second equation. Instead of having an a, I'm going to plug in 200 over b. This b is going to cancel out, and I'm going to be left with b squared. 8 equals 200 times b squared. Divide by 200. And then we're going to simplify the fraction. 8 over 200 is equal to 1 over 25. Take the square root. We've found our first variable, b equals 1/5. We still need a, so I'm going to use this first equation to find a. 200 equals a times 1/5. Multiply both sides by 5 to cancel out the 1/5. A equals 1,000. So then your final answer is going to be y equals 1,000 times 1/5 raised to the x power. The other way you know how to solve systems of equations is using an elimination method. The way the elimination method works is you want to try to cancel out a variable, so then you're only left with one variable in your equation. When it comes to exponentials, we have to set these up a little bit differently. So what you're going to do is, you're going to take your first function, your first equation. You're going to want to use the higher exponent first. And then what you're going to do is you're going to want to divide by the other one. Before, when we used the elimination method, we would cancel things out by adding and subtracting, but that's when we had linear functions. And now that we have exponential functions, we need to use multiplication and division to cancel things out. So when we set up this division problem, the a's will cancel out. So you're left with 8 over 200 on one side, b squared on the other, which is the same thing we had using substitution method, but it was way faster. Take the square root of both sides. B equals 1/5. Plug 1/5, not 1/2. Plug that in to this equation. Multiply by 5. A equals 1,000. So then your final equation is going to be y equals 1,000 times 1 over 5 raised to the x power. So again, Those are your two methods. Elimination, substitution. I don't care which one you use the one that makes the most sense to you.